Hi, I'm Yevinash.
I'm Shazwan.
I'm Sharina,
And I'm Shohan.
and we are from Group 32. So, for today's topic, we're going to talk about submarines. But first, have you guys ever wondered how deep can a submarine go? To solve the problem given, which is to calculate the velocity of the submarine, we need to know the maximum depth of the submarine. This is because the density of the seawater on the surface and inside of the water are different. And for our calculation, we assume the maximum depth of our submarine is 400 meters, making the density of seawater at that level 1030 kg per meter squared. Our calculation is going to be focusing on the primary turbine, and we are assuming the inlet temperature to be 670 degrees Celsius while the outlet temperature is 450 degrees Celsius.
Where E in is equals to E out. So basically in the system, the kinetic energy and the potential energy is 0, and the work in is 0 too because it is a turbine. So there's only work out, and the system is an adiabatic and a steady system. So after putting in all the values, we get W out to be 75 megawatts, and the efficiency of this turbine, we assume it to be 95% because it is impossible to be 100%. So putting in the value with the work out, 75 megawatts multiplying by 0.95, we get the work out to be 71.25 megawatts. So from this equation, we derived another equation to find the velocity. So after putting in the values, the final velocity that we got is 20.8 kiloknot.
So now we're going to find the velocity of the submarine at the surface of the seawater. Firstly, we need to find the drag force by using this drag force formula. The area of the submarine is 113 meters squared. If we divide it by 2 because only half of the submarine is submerged, we will finally get the value of the drag force to be 299 kilonewton. By using the next formula, we can find the value of torque. The n dot represents the rotation per minute of our propeller, which will get 4.67 rotation per second. By using this work shaft formula, we can find the torque, which is 242 kilojoule. Afterwards, we find the thrust force. The radius of our propeller is 3.76 meter, and then by using those values, we can finally get the thrust force to be 644 kilonewton. Afterwards, we minus the thrust force with the drag force to find the net thrust force, which is equivalent to 345 kilonewton. From there, we plug in the numbers to find the torque value, and by using the newly found torque value, we found the work shaft, which is 38 megawatt. From that new work shaft, we will be using the same formula that we used before to calculate the velocity, and we finally find that the velocity of the submarine at surface to be 8.68 meter per second or 16.88 knot.
Okay, so after finding the surface velocity and submerged velocity of the submarine, we can conclude that the submerged velocity is higher than the surface velocity. This is because there are certain drag force which disrupts the velocity on the surface. Therefore, we can conclude that the submerged velocity is higher than the submarine surface velocity.